There existed, in the cloud forests that climb the slopes of the Zunil volcano in Guatemala, a tree that doctors of the ancient world knew by its hand. It's not a metaphor. The flower of that tree, which botanists call Chiranthodendron pentadactylon, is exactly the shape of an open human hand. 5 reddish, fleshy fingers extended upward as if invoking or asking for something. The Maya and the Mexica knew what that shape meant. In the Mesoamerican worldview, the anatomy of the world was not accidental. Plants that resembled parts of the human body had something to say to that body, and this particular one told them, for at least 2,000 years, that it was capable of relieving pain before it even began. When the Franciscan friars first saw it in the highlands of what is now Chiapas in Guatemala, they had a very different reaction. A flower that resembled an outstretched hand, red as blood, which indigenous healers used in ceremonies associated with the body and mind, could only be one thing: the devil's hand. They christened it with that name, and once something bears that name, we know what follows. What we don't know, and what this video will reveal, is that the same plant that the spiritual conquerors of America turned into a symbol of witchcraft was solving a medical problem that Renaissance Europe was completely incapable of addressing. Because while surgeons in Salamanca, Paris, and Rome operated on their patients while they were awake, forcibly holding them against the table and hoping that pain and fear wouldn't kill them before the scalpel was finished, in the temples and markets of Mesoamerica, a protocol already existed for calming the nervous system before surgery. And that protocol began with this flower. 5 centuries later, the active ingredients that give the hand flower its sedative and anxiolytic properties are being studied in laboratories in Europe and North America, and are circulating in supplements sold in pharmacies in Berlin, London, and Mexico City at prices no tzotzil farmer could ever afford. No one on the packaging mentions the origin of this knowledge. No one mentions the tree. No one mentions the hand. This is the story of what was known, what was lost, and what survived without anyone wanting to save it. To understand where this story begins, you have to climb. Climb to 2,800 meters above sea level, where pine and fir mingle with sweet gum and wild epizode, where the clouds don't drift overhead but linger among the trees as if they were part of the grove. It is there, in the cloud forests of southern Mexico, Guatemala, and El Salvador, that the tree that bears this flower grows. It doesn't grow in the lowlands. It doesn't grow in the tropical coastal regions. It is a mountain tree which needs the cold of the high altitudes and the constant humidity to thrive, and which can reach 30 meters in height when left undisturbed. Its bark is gray and fissured. Its leaves are large, like palm fronds, with a dark green upper surface and a lighter underside, covered in soft down that traps the mist. And in the months of November and December, when most of the trees at that latitude have finished flowering, the Chiranthodendron pentadactylon brings forth its blossoms. Each flower lasts only a few days. It emerges slowly from a closed calyx, opens gradually to reveal the 5 reddish stamens fused into a tube ending in outward curving fingers, and falls to the ground when its cycle is complete. If you are under the tree when it blooms, the ground is covered with red hands. The Maya of the highlands, the Tzotzil and Toholabal speakers, the healers of the Amen lineage who learned sacred botany from childhood, gathered these flowers from the ground or cut them directly from the tree using precise procedures. Not just any flower would do, not at any time. Knowing when to pick it, at what stage of its opening, which part of the tree, whether the flower fallen to the ground or the one cut from the branch, was part of the craft. And that craft was learned in direct contact between master and apprentice, over years before anyone could practice it. In the city of Tenochtitlan, which in the 15th century was one of the largest cities in the Western world, with an estimated population of between 200 and 300,000, medicine was a formal, systematized practice with distinct specialists. The Tikitl were the general practitioners, but there were specialized branches. The Tlamatlaque, experts in bones and joints, the Temixuitiani, midwives and obstetricians, and the Texoxotlasque, who practiced something akin to surgery. Mexica surgeons performed sutures using human hair and the mandibles of leafcutter ants, whose bite was used to hold the edges of a wound together while it healed. They knew how to use improvised tourniquets. They drained abscesses. They extracted obsidian and bone projectiles from the flesh of warriors wounded in battle. And in all that surgical repertoire, the question of pain was not unanswered. Bernardino de Sahagún, the Franciscan friar who dedicated nearly 50 years of his life to recording the knowledge of the Nahuatl world before it disappeared, compiled dozens of preparations for pain relief in the Florentine Codex, that 12-volume encyclopedia completed around 1577, which is today one of the most important documents in Mesoamerican history. He mentions Yoyotli, Tliuxochitl, Iztauxiatl, Peyote, and the morning glory seed that the Aztecs called Ololiuqui. And in that catalog, although Sahagún does not always precisely identify which plant corresponds to which preparation, modern researchers have been able to trace references that point to the flower of the hand flower, Flor de Manita, as a component of preparations used before invasive procedures. The most direct evidence comes not from Sahagún, but from the Cruz Badiano Codex, that 1552 manuscript dictated in Nahuatl by the indigenous physician Martín de la Cruz and translated into Latin by Juan Badiano, which is the first medical treatise of the New World written by an indigenous person. The illustrations in this manuscript, painted by Mexica scribes who had first-hand knowledge of plants, include depictions that several 20th-century botanists have identified as Chiranthodendron. The Latin text describes preparations to calm the mind and alleviate the pain that precedes and accompanies certain procedures. It does not use the word anesthesia because that word does not exist in medieval Latin or Nahuatl, but it describes the effect with a precision that, from the distance of 5 centuries, remains unequivocal. What is even less ambiguous is the context of use. The temples of Mesoamerica were not only religious spaces in the sense we understand that word today. They were also hospitals, centers for medical training, and living botanical laboratories. In the gardens of the sacred precinct of Tenochtitlan, whose size and complexity left the Spanish chroniclers speechless, even those who came to destroy everything, species brought from different climates, sometimes hundreds of kilometers away, were carefully cultivated. The handflower tree, which prefers the cool highlands of the south, was valuable enough to be maintained in artificial conditions in the capital of a tropical empire. That tells us something about how highly it was valued. But the story of this plant doesn't begin in Tenochtitlan. It begins much earlier, in the cultures that preceded the Aztec Empire in the highlands of Mesoamerica. Archaeologists working at Teotihuacan, the great city that dominated central Mexico between the 1st and 8th centuries CE, have found depictions of flowers in murals of the southern residential complexes that some researchers link to Chiranthodendron. In these murals, the flowers appear in the hands of figures that specialists identify as priest-physicians in ritual contexts associated with trance and altered states of consciousness. This is not direct proof of medicinal use. However, it suggests that knowledge of this plant did not originate with the Mexica, but was transmitted to them through much older traditions. In the Guatemalan Cuchumatanes, in the region where Mam speakers have lived since before writing existed in the Americas, the healers interviewed by 20th-century ethnobotanists described a tree they called by a name that roughly translates as the one with the hands of time. Not necessarily the same tree, but the same principle, a plant whose shape evokes the human hand and whose function is to act on the nervous system in moments of extreme stress. Mesoamerican civilizations did not share a language, nor did they share a single religion or a single state, but they did share, in many cases, knowledge of certain plants. That knowledge crossed linguistic and political borders with an ease that reveals the existence of networks for the exchange of botanical knowledge that colonial history almost never mentions. In the Soconusco, the coastal strip of what is now Chiapas, which for centuries was one of Mesoamerica's busiest trade routes, merchants transporting cacao, jade, quetzal feathers, and obsidian also carried medicinal plants. The Mexica Pochteca, the great merchants who had their own district in Tenochtitlan and their own patron god, included in their cargo seeds and dried roots of plants that did not grow in central Mexico. Chiranthodendron was part of that trade. Its dried flower, its powdered bark, its concentrated active ingredients in preparations that specialists learned to dose through years of practice traveled along roads that had no wheels but crossed continents. How long this trade had existed when the Spanish arrived is impossible to know for certain, but archaeological evidence and plant genetics studies published in the last 30 years suggest that Chiranthodendron was already being intentionally cultivated and not just harvested from the wild, at least since the late Classic period, that is, between the 6th and 10th centuries CE. Intentionally cultivating it in climatic conditions that did not always coincide with those of its natural habitat required sophisticated agricultural knowledge, understanding its requirements for temperature, humidity, soil, and altitude, knowing when to plant, when to prune, and when and how to harvest. This knowledge was accumulated and transmitted over generations, from doctor to doctor, from gardener to gardener, in an oral tradition that was also a practical, living tradition, subject to constant observation and refinement. In the decades before the arrival of the Spanish, Mexica physicians operated within a system that had its own training institutions. The Calmecac, the school linked to the temples, was where the children of nobles learned writing, astronomy, the calendar, and also medicine. But the deepest botanical knowledge was not transmitted solely in the classrooms of the Calmecac. It was also transmitted in the royal medicinal gardens, in the temples of Xipe Totec and Tlaloc, where plants and deities were intertwined, and in the intimate relationship between an experienced tisital, physician, and an apprentice who, from the age of 9 or 10, began to learn the names of plants, their seasons, their useful parts, and their incompatibilities. The gardens of Huaxtepec, which Moctezuma Ilhuicamina ordered built in what is now Morelos around 1465, were the most elaborate expression of this system. According to the chronicles of Bernal Díaz del Castillo and Francisco López de Gomara, these gardens astonished even the conquistadors themselves with their size, variety, and organization. They had irrigation canals. They contained species brought from every corner of the Inca Empire. They had xochipilque, specialized gardeners whose sole purpose was to care for certain plants and transmit the knowledge of their uses. When Hernán Cortés visited them in 1520, a year before the fall of Tenochtitlan, he recognized in them something that surpassed what he had seen in the royal gardens of Spain. He didn't write it in those exact words, but he hinted at it when describing the variety and sophistication of what was cultivated there. Chiranthodendron was not the only plant in the system, nor was it even the most important. But its case illustrates with particular clarity a principle that runs throughout the history of Mesoamerican medicine. The knowledge of pain, and of pain control, was not a dark area of indigenous knowledge. It was one of its most developed specializations. Let's consider what it meant to face a surgical procedure in the 15th century. In Europe, the situation was brutal. Before the use of ether as a general anesthetic, which wasn't introduced into Western medical practice until 1846, surgeons worked at breakneck speed precisely because they couldn't alleviate their patients' pain. Speed was the only form of compassion available. The most celebrated surgeons of medieval and Renaissance Europe were those who completed an amputation in under 3 minutes. The conscious patient, held down by assistants, with a leather or wooden gag between their teeth to prevent them from breaking from clenching, endured as best they could. Many didn't. The traumatic shock of uncontrolled pain killed as many patients as the procedures themselves. In Mesoamerica, that was not the only path available. Pre-Hispanic physicians knew several categories of preparations that acted on the nervous system. These included smoke inhalants, concentrated infusions, oils applied to the skin, and inhalations of plant vapors that we now know contain compounds active on the anxiety receptors of the human brain. Chiranthodendron was one of the tools in this arsenal. Not the only one, but certainly one of the most specific for what we would now call pre-surgical sedation, reducing the activity of the nervous system, calming the fear response, and making the subsequent pain more manageable. When Martín de la Cruz recorded his knowledge in 1552, 13 years would pass before a decree from the First Mexican Provincial Council of 1555 placed the supervision of indigenous medical practices in the hands of the Church. That decree did not explicitly prohibit indigenous medicine. It didn't need to, simply requiring that any medical practice be supervised by a priest or a physician trained in Europe was enough to set the system in motion. Because the condition for such supervision was that the indigenous healer be able to explain, in terms understandable to a Franciscan friar, what he was doing and why. And what the Tikal were doing with Chiranthodendron was not easily explained in terms of the medieval Galenism that the friars brought from Spain. Galenism, the medical system based on the ideas of the Greek physician Galen, which dominated European medicine for nearly 1,500 years, understood disease as an imbalance among four humors: blood, yellow bile, black bile, and phlegm. Galenic therapeutics were organized around the idea of restoring this balance through diets, bloodletting, purges, and preparations of plants classified according to their properties of heat, cold, dampness, and dryness. It was a rational and coherent system within its own terms, but it lacked the conceptual framework to understand what Chiranthodendron did to the nervous system, because the concept of a nervous system as such did not exist in 16th century Galenic medicine. What the friars could understand was the shape of the flower. And the shape of the flower, with its 5 outstretched reddish fingers, reminded them of a demonic hand. Friar Toribio de Benavente, known as Motolinia, one of the first 12 Franciscans to arrive in New Spain in 1524, was perhaps the first to record the hand flower with this symbolic interpretation. In his memorials, written between 1500 and 1540, he describes the plant as one of the instruments of the devil that indigenous healers used in their healing rituals. The description is important not so much for what it says about the tree itself as for what it reveals about the mechanism of persecution. In 16th century Franciscan thought, the visual appearance of a plant could be enough to condemn its use. It was not necessary to demonstrate a harmful effect. Its mere appearance sufficed. This principle, which historians of science call the doctrine of signatures in its inverted colonial version, where resemblance to something diabolical indicated an infernal origin, just as resemblance to an organ indicated in the original European system that it was good for that organ, was one of the most destructive tools of medical conquest. Not because it was efficient at destroying plants, which are difficult to destroy, but because it was efficient at destroying the people who used them, who are much more vulnerable. Healers who continued to use the Manita flower in their preparations after the prohibition risked not only a fine or administrative proceedings, they risked denunciation before the tribunal of the Holy Office of the Inquisition, formally established in New Spain in 1571, which had jurisdiction over Creoles and mestizos, and whose shadow was enough to intimidate any population. Pure indigenous people, in theory, did not fall under the direct jurisdiction of the Inquisition, but were subject to ordinary ecclesiastical courts, which could impose penances, confiscations, and banishments. The effect on the transmission of medical knowledge was catastrophic and silent. There was not a single bonfire to burn the Chiranthodendron. There were decades of accumulated pressure that led indigenous healers to learn not to teach what they knew, or to teach it only on the margins, only to those they could trust, only with language sufficiently disguised to remain unrecognizable to an inquisitorial friar. The second major threat was the reorganization of the physical space where knowledge was transmitted. The gardens of Huaxtepec, that botanical marvel Cortés visited in 1520, were in the hands of the Hospitallers of San Hipólito by 1570. The space was converted into a hospital for Spaniards, and the botanical collections that had no immediate recognizable use for Galenic medicine were abandoned, uprooted, or replaced with European plants. This was not a careless act of vandalism. It was a systematic administrative decision made within the context of a colonial policy that considered indigenous botany, at best, a folkloric curiosity, and at worst, a diabolical practice. Francisco Hernández de Toledo, the physician whom Philip II sent to New Spain between 1570 and 1577 to catalogue American nature, recorded Chiranthodendron in his monumental Natural History of New Spain. Hernández was a physician trained in Salamanca, knowledgeable in classical Galenism, but also a rigorous observer with a genuine ability to recognize the internal logic of indigenous medical knowledge. His notes on the hand flower describe the properties that indigenous informants reported to him: the ability to calm, to reduce fear, to alleviate certain types of pain, without attempting to forcefully translate them into European humoral vocabulary. It is an honest description, professional, the kind we would recognize today as responsible ethnobotany. The 16 volumes of manuscripts that Hernandez produced arrived at El Escorial. Philip II read them, kept them, and did not authorize their complete publication. What circulated of Hernandez's work during the following centuries were censored extracts, summaries that the Jesuits published in Mexico City in 1651. The original manuscript was destroyed in the fire that consumed the library of El Escorial in 1671. With it went the most complete description that a European physician had produced of the properties of Chiranthodendron, and the tree remained alone in its fog forest. It didn't disappear. Trees are more resilient than manuscripts. In the herb markets of Oaxaca, in the Tlacolula market on Sundays, in the apothecaries of the Tzotzil healers of San Cristobal de las Casas, the hand flower continued to be sold, in different forms, with different names depending on the region, without anyone actively persecuting it because no one with enough power knew it existed anymore. It had descended into invisibility. And in that invisibility, it survived, from hand to hand, from healer to apprentice, from market to market, for 200, 300, 400 years. But what did not survive with the same integrity was the systematized knowledge of its use in surgical contexts. That knowledge required an institution to be transmitted. It required the gardens of Huaxtepec. It required the Calmecac. It required the formal relationship between the experienced teetotal and the medical student. When those institutions were dismantled, the royal gardens in the early colonial years, the Calmecac prohibited by the Franciscans in the decrees of the First Mexican Provincial Council of 1555, what was lost was not the plant itself, but the architecture of knowledge that sustained it. A plant without the institution that upholds its knowledge of use is only half a plant. It survives as food, as dye, as a botanical curiosity. But it loses the most sophisticated layer of its history, the knowledge of the exact dose, the specific preparation, the combination with other plants to enhance or moderate the effect, the protocol that made the difference between an effective pre-surgical sedative and a decorative or, in the worst case, dangerous infusion. Dr. Francisco Brambilla, one of the few physicians in New Spain during the 17th century who attempted to bridge the gap between Galenic medicine and indigenous herbalism, left in his personal papers, now scattered between the General Archive of the Nation of Mexico and the National Library of Spain, a note about the hand flower, Flor de Manita, that researchers from the National Autonomous University of Mexico located in the 1990s. Brambilla wrote, with the caution of someone who knows he is treading on dangerous ground, that the healers of the Chiapas highlands used the flower in combination with other plants to calm the spirits of patients who were to undergo incisions. He did not use the word surgery. He did not use the word anesthesia. But he described the effect with enough precision for any modern physician to recognize what he was talking about. That note was written around the year 1640. By then, surgeons in Mexico City, trained in European medicine, were still operating on their patients without any sedation. They would continue to do so for another 200 years. What Brambilla had witnessed in the highlands of Chiapas, and which he wisely recorded in private notes rather than publishing, was the surviving practice of a medical system that the colony had declared incompatible with civilization. This system, in terms of pain management, held a centuries-long advantage over Europe, and at the time Brambilla was taking his notes, it was being slowly eroded by the accumulated pressure of 200 years of prohibition, ridicule, and institutional silence. The last physician in the colonial tradition of New Spain to take the Manita flower seriously as a therapeutic tool left his record around 1720, according to studies by the medical historian Germán Somolinos d'Ardois. After that date, Chiranthodendron practically disappears from formal medical treatises. Not from the markets, not from the memories of traditional healers, but it does disappear from established medicine, the medicine of universities, the medicine that left written records and that was considered, by the institutions of late colonial power, the only medicine that mattered. And by the year 1800, when modern scientific medicine was beginning to emerge in Europe with its methods of systematic observation, its first rudimentary clinical trials, and its first attempt to understand the human body in terms other than Galenic humor, Chiranthodendron was simply invisible to that medicine. Not suppressed, invisible. What doesn't exist in the published literature doesn't exist for science. And the published literature in the colonial and post-colonial world was in the hands of those who had decided what deserved to be written and what didn't. The tree continued to grow in its cloud forests. The red hands continued to fall to the ground in November. Some healer in Huixtan or Zinacantan continued to gather the flowers for preparations her patients requested when fear or pain became unbearable. But the thread that connected this surviving practice to the great pre-Hispanic surgical tradition, to the gardens of Huaxtepec, to the classrooms of the Calmecac, to the notes of Francisco Hernandez, and to the manuscript of Martín de la Cruz, that thread had been broken. And nobody, in the next 2 centuries, would bother to look for it. And then the laboratories began to ask about the tree that the friars had called the devil's hand. It wasn't immediate. It wasn't clean. It was the kind of rediscovery that happens when someone, in some university lab, stumbles across a forgotten reference in a dusty archive and decides, almost out of curiosity, to see if there's anything there. That's how most stories of scientific rescue begin. Not with a deliberate search, but with a lucky accident, with a footnote that no one had read in 200 years, with an ethnobotanist arriving at a market at the exact moment a healer is selling dried flowers from a plant he doesn't recognize. In the case of Chiranthodendron pentadactylon, the moment of formal scientific recovery arrived in the 1970s in the laboratories of the Institute of Chemistry at the National Autonomous University of Mexico. The research group working at that time on Mexican medicinal plants documented in early colonial sources had a systematic project to take the plants that appeared in the Cruz Badiano Codex and the Florentine Codex, to identify them botanically with certainty when possible, and to subject them to phytochemical analysis to see what they contained. They did not start from the hypothesis that the plants were medicinally active. They started from the simplest and most rigorous question: what's inside? What they found inside the Chiranthodendron was, by the standards of pharmacology in the 70s, surprising. The bark, leaves, and especially the flowers of the tree contained a combination of flavonoids, tannins, and alkaloids whose profile was consistent with the activity described in colonial texts. The identified flavonoids included compounds from the isoflavone family, which have a demonstrable affinity for gamma-aminobutyric acid receptors, known by its acronym GABA, the main inhibitory neurotransmitter in the human brain. In simpler terms, the compounds that the Institute of Chemistry found in the Manita flower act on the same receptor system as benzodiazepines, the family of medications we routinely use today for anxiety, pre-surgical sedation, and insomnia. Valium, Lexotan, Rivotril, they all work on GABA receptors. The Manita flower does too. This does not mean that the hand flower is equivalent to a benzodiazepine. It is not. Its potency is lower, its exact mechanism is different, and its side effects and risks are not the same. But it does mean that the pre-Hispanic healers who used this flower as a sedative before painful procedures were not operating out of superstition. They were using a modulator of the central nervous system whose chemical logic, even if they lacked the words to describe it, was real and effective. The results from the Institute of Chemistry were published in the following years in specialized phytochemistry journals, and during the next decade, other research groups, both in Mexico and abroad, began to confirm and expand upon these findings. A study from the University of Guadalajara, published in the Journal of Ethnopharmacology in the mid-1980s, documented the use of Chiranthodendron by tzotzil healers from the highlands of Chiapas in preparations for managing what they called susto, fright, and angustia graves, severe anxiety. terms that in the indigenous medical system described states that modern psychiatry would recognize as acute anxiety disorder. The doses the healers used, according to the descriptions they provided to the researchers, were carefully controlled. It wasn't simply taking the flower like chamomile tea, it was a specific preparation with specific quantities at specific times for specific conditions. The knowledge had survived, fragmented and transformed, but it had survived. In the late 1990s, the work began to resonate beyond Mexico. Researchers at the University of Illinois at Chicago, coordinating a larger project to document Mesoamerican medicinal plants used for neurological disorders, included Chiranthodendron in their catalog and published a comparative analysis of its flavonoid profile with that of other plants used worldwide for anxiety management in phytomedicine in 2002. The study concluded that the hand tree, as the researchers informally called it, had one of the highest concentrations of compounds with GABA receptor activity ever documented in a medicinal plant from the Americas. There was no newspaper headline, there was no press conference. Ethnobotanical and phytochemical findings rarely make headlines until someone turns them into a product. And that, in the case of Chiranthodendron, was about to happen in a way that no one in the highlands of Chiapas could have seen coming. Because while university researchers were publishing their findings in restricted access journals, the private sector was reading them. Companies that manufacture nutritional supplements and wellness products, a market that generates astronomical sums each year in English-speaking countries and Germany, have entire departments dedicated to monitoring precisely these kinds of publications. They look for new ingredients, preferably with enough scientific backing to be used in marketing, but not enough for regulatory agencies to classify them as drugs, which would subject them to costly clinical trials. The hand flower met exactly these conditions in the early 2000s. Solid phytochemical support, documented traditional use spanning centuries, and no patents protecting the knowledge about it. It's important to understand how the intellectual property system works in the world of natural ingredients. A plant itself cannot be patented, nor can a naturally occurring compound. What can be patented is a specific extraction process, a particular formulation, a combination of compounds in specific proportions, or a particular method of use. Pharmaceutical companies and supplement manufacturers have spent decades perfecting the art of taking traditional knowledge about a plant, identifying its active compounds, developing a proprietary process to isolate and concentrate them, and patenting that process. The result is that the knowledge an indigenous community accumulated over centuries becomes an asset belonging to a corporation headquartered in Zug or Delaware. It's not always outright theft. Sometimes there's collaboration. Sometimes there's compensation. Sometimes the researchers who publish the original findings have agreements with their universities that guarantee some kind of retribution to the communities of origin. But more often than it should be, the process is simply extraction. Someone reads the paper, identifies the compound, develops the formula, registers the patent, and the community that showed the world that the plant existed and what it was used for receives nothing. The Convention on Biological Diversity, signed in 1992 at the Earth Summit in Rio de Janeiro, established the principle of the fair and equitable sharing of benefits arising from the utilization of genetic resources. The Nagoya Protocol, signed in 2010 and in force since 2014, created a more specific framework for that sharing. But the implementation of that framework is uneven, slow, and full of exceptions that the best corporate lawyers know how to exploit. In the specific case of Chiranthodendron, the active ingredients identified by the Institute of Chemistry at the National Autonomous University of Mexico in the 1970s, and subsequently confirmed and expanded upon by research, now appear as ingredients in anxiety management supplements sold in natural product stores in Berlin, Amsterdam, Toronto, and Mexico City. The labeling varies. Some mention the botanical name. Most use the name of the extract or the isolated compound. None, as far as researchers at the National University have been able to document, includes any reference to the origin of the knowledge, neither to the Mexica Ticketal, nor to the Tzotzil healers of Huixtan, nor to the Cruz Badiano Codex, nor to the gardens of Huaxtepec, where the tree was cultivated with a dedication and knowledge that took generations to accumulate. The price of those supplements in stores in Berlin or Toronto is unattainable for any inhabitant of the highlands of Chiapas. There is a detail in this story that researchers at the Center for Research and Advanced Studies of the National Polytechnic Institute found particularly revealing when they began working on Chiranthodendron in the early 2000s. By comparing the phytochemical profiles of the wild plant with those of specimens cultivated in university botanical gardens, they discovered something that colonial documents had suggested without explicitly stating it. The concentration of active compounds varies significantly depending on growing conditions, altitude, rainfall, and, above all, the time of harvest. Specimens harvested at the specific stage of flower opening preferred by pre-Hispanic healers, not the fully open flower, but the one about to open, when the calyx has just separated, had concentrations of anxiolytic compounds up to 3 times higher than those of fully developed flowers. That knowledge wasn't in any paper. It wasn't in any European treatise. It was in the practice of the healers who had inherited, in a fragmented but real way, the tradition of their predecessors. It was practical knowledge accumulated over generations of observation and experimentation, and it took modern science 30 years to rediscover it on its own. Researchers from the University of Salamanca, in collaboration with the group from the Institute of Chemistry at the National University of Spain, published a study in the Journal of Agricultural and Food Chemistry in 2016 characterizing the flavonoids of Chiranthodendron, which is currently the most comprehensive reference available in the scientific literature on this plant. The study identified 19 different flavonoid compounds, 7 of which showed demonstrable activity in vitro GABA receptor binding assays, that is, under laboratory conditions that allow direct measurement of how much the compounds bind to the receptors that produce the sedative effect. The authors of the study were careful in their conclusions, as befits rigorous scientists. The in vitro results are indicative, not proof of clinical efficacy in humans. For that, controlled clinical trials, which have not yet been conducted, are necessary. But the in vitro results are robust enough for the Salamanca researchers to write in their conclusions, with the restraint required by academic language, that the tradition of pre-surgical use of Chiranthodendron, documented in 16th-century Mesoamerican sources, has a plausible pharmacological basis that would justify further clinical research. In the vocabulary of peer-reviewed science, that sentence is the equivalent of saying, "The Mexica physicians were right." Let's consider what that means. In Europe, general anesthesia didn't exist until 1846, when dentist William Morton administered sulfuric ether to a patient at Massachusetts General Hospital in Boston before an audience of skeptical physicians. That moment is considered the beginning of modern anesthesiology. Before that date, all major surgery was performed without sedation. Thousands of patients died from traumatic shock, from sustained terror, from the combination of pain and fear that the human body is not designed to withstand above a certain threshold. In Mesoamerica, at least since the 15th century and probably long before, a protocol existed to reduce that fear and pain before the intervention began. That protocol used a plant that modern science has confirmed contains the compounds necessary to produce precisely that effect. And that protocol was destroyed, marginalized, made invisible, by a combination of ignorance, religious prejudice, and colonial politics, at the exact same historical period in which Europe was killing its surgical patients for lack of precisely that knowledge. It is not an abstract paradox. It is a concrete human figure, although impossible to calculate exactly. How many people died of uncontrollable pain in the operating rooms of Madrid, Seville, Mexico City, and Lima between 1521 and 1846, who could have lived if the knowledge that the Mexica doctors had about Chiranthodendron had been incorporated into colonial medicine instead of suppressed? That figure doesn't exist in any record. No one calculated it. No one considered it relevant. Those who died in colonial operating rooms died of pain, and that was normal, and what was normal required no explanation. Here we must pause to consider a name that appears in passing in several studies and deserves more attention than it usually receives. His name is Gregorio Lopez, and he lived in New Spain between 1542 and 1596. He was a Spanish hermit of obscure origin. Some biographers suggest he may have been the illegitimate son of Philip II, although this was never confirmed, who spent decades living among the indigenous communities of central Mexico, learning their language, their plants, and their medical practices. He wrote a treatise called Tesoro de Medicinas para varias enfermedades, Treasury of Medicines for Various Diseases, published posthumously in 1672, which is one of the few texts from the colonial period that sincerely attempts to integrate indigenous botany with European medicine of the time. Lopez mentions herbal preparations that calm the agitation of the spirit before painful cures. He doesn't explicitly identify Chiranthodendron. His plant descriptions aren't always botanically precise enough for certain identification, but the profile of what he describes matches what we know about the handflower. Lopez was beatified by the Catholic Church in 1984 and is considered a pioneer of folk medicine in Mexico. But his work, despite his beatification, wasn't systematically studied in relation to modern pharmacology until researchers at the Interdisciplinary Research Center for Regional Integral Development of the National Polytechnic Institute began that work in the early 2010s. When researchers compared the preparations Lopez described with the current phytochemical profiles of the plants he mentioned, they found that several of those preparations had a coherent pharmacological logic from a modern perspective. Not always, not in every case, but with a frequency that could not be attributed to chance. What Lopez had learned from the indigenous communities, and which he had wisely recorded rather than condemned, was empirical science at work. It was accumulated observation, refined by generations of use, that had arrived at valid conclusions by a path different from controlled experimentation, but no less rigorous in its own right. That is perhaps the most important aspect of this story, and the one that is hardest to incorporate into the modern scientific mindset: the difference between method and result. Pre-Hispanic medicine did not use the modern scientific method. It had no control groups, it had no double-blind studies, it had no inferential statistics. But it had centuries of observation of large populations. It had corrective mechanisms based on practical results. It had its own epistemology, even if it didn't call it that distinguished between what worked and what didn't. And when that epistemology concluded that Chiranthodendron was useful for calming fear and pain before a painful procedure, it reached that conclusion because it was true. If these stories grab you, subscribe to the channel, because the next one comes from another archive that no one wanted to open for 400 years, and it promises to be at least as unsettling. As for the tree today, the situation has a dimension that botanists from the National University and the Institute of Ecology have been documenting with growing concern since the 1990s. The Chiranthodendron pentadactylon is classified by the official Mexican standard as a species subject to special protection. This is not a designation of immediate extinction, but it is an official recognition that its populations are vulnerable enough to warrant attention. Its natural distribution is fragmented. It lives in patches of cloud forest concentrated in the states of Chiapas and Oaxaca, in the highlands of Guatemala, and in small areas of El Salvador and Honduras. These cloud forests are among the most threatened ecosystems on the planet. Agricultural expansion, illegal logging, disruption of rainfall patterns due to climate change, and habitat fragmentation by roads are reducing them at a rate that forest cover studies from the Center for Research in Environmental Geography at the National University quantify at several thousand hectares per year. The tree doesn't grow in lowlands. It's not adapted to the coastal heat or the dryness of northern Mexico. It needs precisely the type of microclimate that is disappearing most rapidly. And although it can be cultivated in botanical gardens and specialized nurseries, its reproduction outside its natural habitat is slow and expensive. The specimens at the National University Botanical Garden in Mexico City are a testament to conservation efforts, but they are not a solution to the underlying problem. For the Tzotzil and Celtal communities of the Chiapas highlands, who have kept the use of the plant alive through 5 centuries of external pressure, the threat to the cloud forests is not just an ecological problem. It is a direct threat to their medical system and their cultural identity. The community herbalists that Doctors Without Borders and the National Indigenous Institute have documented in that region since the 1980s incorporate Chiranthodendron as one of the components of their pharmacopoeia for the treatment of anxiety disorders and post-traumatic stress disorder, which are prevalent in these communities, marked by decades of armed conflict, displacement, and structural poverty. Not as the sole treatment, not as a substitute for psychiatric care when it is necessary and accessible, but as part of a comprehensive care system that Mexican public medicine, for all its merit, has been unable to replicate in hard-to-reach areas. The recovery of knowledge about Chiranthodendron, therefore, has an immediate practical dimension that goes beyond history and pharmacology. If the clinical trials that researchers from Salamanca and the National University are calling for in their publications were ever to be carried out, and if they confirmed in humans the anxiolytic activity suggested by in vitro studies, the hand tree could contribute to solving a major public health problem: access to treatment for anxiety and stress in low-income rural communities throughout Latin America. Not as a replacement for modern psychopharmacology, but as a verified, accessible, locally cultivable complement, rooted in a cultural tradition that gives it meaning within the understanding of the very communities that would use it. That would be the kind of justice that history rarely grants, that what was suppressed is not only recognized as valid, but that its recognition serves the very communities from which it was taken. If you'd like to cultivate the hand flower, or simply observe it up close, the Botanical Garden of the National Autonomous University of Mexico, UNAM, in University City, maintains specimens accessible to the public. The Ethno-Botanical Garden of the Santo Domingo Cultural Center in Oaxaca also has specimens as part of a larger project to recover Mesoamerican medicinal plants that deserves a visit and support. In the medicinal herb markets of San Cristobal de las Casas, especially in the Santo Tomas market, where tzotzil vendors have been present for generations, it's possible to find the dried flower under the names hand flower or monkey hand flower, with prices that reflect the tree's increasing scarcity in the wild. An important warning: if you ever decide to use this plant as a remedy, do so with guidance from someone who knows its actual uses, not from an internet video. The GABA receptor activity that makes the hand flower potentially useful as an anxiolytic also makes it potentially problematic in combination with alcohol, prescription benzodiazepines, or other central nervous system depressants. Dosage knowledge is an inseparable part of understanding the plant, and that knowledge is best imparted in person at the Tlacolula market on a Sunday morning by a herbalist who has been working with the plant for 40 years than anywhere else. Subscribe to this channel. Every week we open a chapter of nature's archive that should have been opened centuries ago. The hand-shaped tree continues to grow in its cloud forests. In November, when the cold descends from the volcanoes and the dampness settles among the fir and pine trees, the red hands fall to the ground once more. No one burns them. No one blesses them. No one calls them demonic. They fall silently, as they always have, waiting for someone to bend down and pick them up, remembering their purpose.